Hi, I'm Doyle Bishop with Tulsa Heaters Midstream. On this channel, you can expect to hear about all things related to process heating, but sometimes the topics aren't technical, but most of the time they are, so thanks for joining. Hi, I'm Doyle Bishop with Tulsa Heaters Midstream. Today I want to talk to you about burning a waste gas in a fired heater. So we get this question many times. Hey, we've got this waste gas in the process. We really don't want to send it to a flare. We don't have a thermal oxidizer. Can we send it to your heater? Can you destruct that waste gas in your heater? So the question is a little bit, well, we have to dig a little deeper. How much waste gas do we have? What is the composition? Does it self-sustain flame? What are we trying to destruct here? What level of destruction do we need to get to? Is the heater operated continuously at normal rates all the time, or is it up and down? So we have to dig a little bit deeper. So let's unpack some of those questions for a second. So I'm going to start by drawing a heater again, as I usually do. So I've got a heater, it's got a convection section, and then it's got a radiant section like this. I'm going to draw it in coil format. And then I've got a burner at one end, okay? Fuel's going into this burner. Let's just say natural gas is our fuel. And then air from a blower is going into the burner, because I have to have obviously air and fuel for a burner. So one question is where do I stick it? Where would I put this waste gas that needs to be destructed? Well, where's the hottest part of the box? The hottest part of the box is in what we call the radiant section, which is, as you might imagine, where the flame is. So now that I've drawn the flame, where's the hottest part now? Well, the hottest part's going to be out towards the back end of this flame. This will be the hottest location in a fired heater. A typical temperature at this location might be 2,300 degrees in that flame. So when we have a waste gas that we want to destruct, basically that means we need to burn it. We're trying to burn it to get it to compounds that are safe, like CO2, water, SO2, safer compounds than the state that it's in. Because the state that it's in, it may have some bad actors in it, like H2S or some hydrocarbons that are heavy. So essentially you're trying to burn it or oxidize it. So to do that, obviously I need air, I need oxygen, and I need a high temperature environment. Almost all components of a waste gas that you want to burn or destruct, almost all of them will burn out in the 1,400 degree range. If I can get a mixture up 1,400 in the presence of some oxygen, I can get it to burn. So typically a waste gas is injected in a burner like this. We just put a lance inside that burner and inject it into the flame itself. Because obviously the hotter we get it, if we can get it to 2,300 degrees, the better destruction that we get. Now, with that said, if the waste gas is highly inert, if it has a bunch of CO2 in it, or a bunch of nitrogen, a bunch of water, it can have the reverse effect. It's like a fire extinguisher. So we'll look at what the mass flow rate is, what the composition is, and we might want to inject it at a different location. We might want to have a plenum out here and inject it into multiple injection points, not directly into the flame, but kind of at the flame periphery, so we don't put the flame out. So we got to look at the composition before we make a design out and roll with it. So the other thing about heaters that you have to think about is a heater is really controlled by this process outlet temperature. Right there, that's typically what controls the fuel gas, not typically, invariably. That process outlet temperature controls it. So let's say you have a situation where this process fluid is going somewhere to users, and hey, it doesn't need much heat for whatever reason, we got more heat than we want. So what happens? Well, that says, hey, this is hotter than we want. Pinch this back, lower the fuel going into here. Well, guess what happens when that happens? Well, this gets cold in here. You're still satisfying the heat requirements for the fluid, but maybe you're not satisfying the heat requirements for destruction of this waste gas. Maybe you're going less than 1400, maybe you're getting down to 1100 degrees or less. The heater process is happy, it's good, we're happy with this temperature. What's not happy is I'm not destructing the waste gas. So you have to look at the system and say, are there times where I'm going to cut back on natural gas, it's going to be too cold in this heater, I'm not going to get good destruction of this waste gas. If that's the case, then your option is hey, let's take this to a thermal oxidizer, which controls based on the flue gas temperature and not a process fluid temperature. So in summary, we can do waste gas in a heater. You have to ask yourself, as the user, are there going to be times where we don't need high firing rates, I don't achieve a flue gas temperature in this box, and therefore I can't get good destruction. Hey, thanks for joining. If you enjoyed this episode, hit like or subscribe to get more information about process heating and Tulsa Heaters Midstream.